Hello everyone, my name is Chris Edwards and today we're going to write a SQL query. Our problem today involves a relatively common data transformation technique that you can employ when you need data that is split across multiple rows to instead be split across multiple columns in the same row. A retail store manager wants to get a summary of how many products of each product type the store sold during the week of February 16, 2025. The store's central database has an existing summary table called Product Sales with the following structure. Each row in the table tells you the total quantity sold of the given product type on the given date. While this is helpful, the manager would really like this report to have a different structure. Specifically, the manager wants the following structure, where each date during the week of February 16th to February 22nd appears in precisely one row, and each product type's sales quantities are summarized in a dedicated column for that product type. We need to write a SQL query that selects from the product sales table and produces the report shown here for the week of February 16th through February 22nd. Some additional notes here. The report should contain all dates from the week in question, even dates on which the store saw no sales, like the 18th here. If the store saw no sales of a given product type on a given date, then the report should return 0 for that entry. You can assume that the store only sells the product types toy, book, and clothing. It is a strange, fairly restrictive store. And the results of the query you write should be returned sorted chronologically by sale date, as you see here. All right, well, that is all of the setup for today. If you want to have a crack at solving this problem yourself, there are links in the video description to this full problem statement and instructions on how to replicate this coding environment on your local machine. Feel free to pause the video now and come back later for a solution walkthrough coming right up. All right, welcome back everyone. We will now take a look at a possible solution to this problem. The way I see it, there are two main things that separate the product sales table from the final output that we are looking for. The first difference is that the product sales table contains one row for each product type sold on each date, whereas the requested report has only one row per date and separate columns with the quantity sold on that date for each product type. The second difference is that the product sales table only has data for days on which there were sales, whereas our manager wants a report with rows for every day in the week, whether or not there were sales on those days. I'm going to go ahead and tackle difference number 1 first, and then refine the solution by addressing difference number 2. So we have multiple rows per product type, and we want multiple columns instead. Transposing rows to columns like this is a very common type of data transformation that may be familiar to many of you, especially those versed in Microsoft Excel. This kind of transformation is generally called a pivot or pivot table, and is a common requirement in stakeholder-facing business intelligence applications, dashboards, reports, and the like. While there are some database systems like Snowflake that have first-class support for pivoting, with dedicated syntax and everything, many databases do not. I use Postgres in these videos, and while Postgres technically has an extension you can install called TableFunc that enables something like a dedicated pivot function, the base Postgres flavor of SQL does not have such functionality. For that reason, and in order to make this solution more generally applicable, I'm going to show you a way to produce a pivoted structure using standard SQL without using any special database-specific functionality. Okay, let's start by taking a look at the product sales table to remind ourselves what we are dealing with. We have a sale date column, which we want in the final output, so I'll just go ahead and put that in our select query here. And then we also have these two columns for product type and quantity. Now in the final output, we actually want three separate quantity columns, each for the different product types. So let's sketch out a skeleton of that right now. So our final select statement will need to look something like this with these three separate quantity columns, but right now all three quantity columns have the same data, and we want them to each contain the quantity data for just that one column's product type. So we need some kind of conditional logic to tell the query to only pull the toy data into the toy quantity column, only pull the book data into the book quantity column, and so on. Now, how do you write conditional logic in SQL? Generally, you would use a case statement, and that's what we are going to do here. So to write a case statement, you need, at a minimum, a condition and a value to return when that condition is true. In our case, the value we want to return is the quantity column from product sales, and the condition needs to return true for any rows associated with the current column's product type. In other words, when product type equals toy, book, etc. Let's give that a try real quick and see how we're doing. There's some definite progress here. We can see that each product-specific column now only contains sale quantities for that product. For example, on February 16th, we see it lists 14 toys sold, and that is in fact the correct quantity for toys on that date. This still isn't quite what we want because there are still multiple rows per date instead of all the quantities collapsing into one summary row. Also, when no units of a particular product type were sold on a given date, the query is currently returning null instead of 0 like we want. Let's fix this second issue first. As you may know if you've used case statements before, you can use an optional else clause to define a fallback or default return value if none of your when conditions are met. So let's give all of our case statements a default of 0. Let's go ahead. I need to switch those. Okay. Let's go ahead and run that. Okay, better now. Now we have zeros instead of nulls. But now we need to figure out how to collapse the rows so there is only one row per date. And what can you do in SQL when you want to keep distinct values in one column while combining or consolidating the values in the other columns? You can use a group by statement. You can aggregate. So we want to group by sale date to ensure that the output contains exactly one row per date. And we need to use an aggregation function on the other columns to combine their values in some way. This is kind of an unusual situation since the main goal of the aggregation is not to meaningfully aggregate multiple values. Instead, we have a situation where we know there is at most one useful value per date in each column. So we just want to construct a single row that has that useful value from each column if it exists. There are actually several aggregation functions that will work here, but the most obvious ones to me are either sum or max. I'm going to arbitrarily go with sum and give that a try. Run this. All right, this is great. We have successfully consolidated down to one summary row for each date that was in the original product sales table. And as you can see, for those dates, our output is exactly matching the expected output shown on the left here. The only thing left to do now is to include the missing dates, those dates on which the store saw no sales. Luckily, there is an extremely useful design pattern of sorts that can help us out here, and it is generally called a spine. In our specific case, you would call it a date spine, but the same principle works with any kind of categorical data that you are aggregating. Basically, you are in a situation where you want to summarize all members of some set, but you only have data for some of the members. The solution is to simply create a new data set consisting of all distinct members of the set that you are trying to summarize, and then use that as your starting point for the analysis. Typically, this looks like defining a CTE or a temp table and then left joining from that to the actual data set you are analyzing. This will be easier to understand in context, so let's give this a try with our problem. I have prepared a version of the query that uses a simple date spine that I have made here with this values clause, just manually listing out all the dates between February 16th and February 22nd. Once I have defined this date spine CTE, it can then serve as the spine, quote unquote, upon which the body of my analysis depends. I select from the date spine CTE, then left join to my original source table, product sales, such that all dates from the date spine will be included in my output, as well as any sales quantities for those dates that had sales. Everything else that we wrote previously with the case statements and whatnot all still works, but now we have rows in our output for all the dates we care about, including the dates that had no sales, like the 18th. And that's pretty much it. We've covered a general strategy for pivoting a table using standard SQL and shown the utility of defining a helper dataset called a spine when source data that you want to summarize has missing values. Before we wrap up for today, I want to add a bit of additional commentary about each of these topics for those who are interested. First off, you may notice that in order to create our pivot table, we had to manually list off columns and case statement logic for each value in the column we were pivoting. This is not ideal because it requires us to know in advance which values to expect, for example, which products the store sells. And it's also, frankly, a bit of a pain. Imagine the store sold 1,000 products. That would be a lot of columns to define manually. Unfortunately, these are basically just limitations of this method of pivoting. There are various ways to mitigate these issues, however. Some, but not all, database systems that give you dedicated pivot syntax also have an option for a so-called dynamic pivot, where the database does all of that stuff in the background for you, and you just tell it what columns to pivot on. If you aren't using one of those databases, though, you can always handle this yourself in application code. For example, you could write something in Python that retrieved all unique values in the column you want to pivot, and then used that to generate and run the appropriate SQL code to pivot on those values. Lastly, on the subject of spines, I manually defined this date spine using a values clause, but there are usually many other ways to do it. For example, sometimes the database system has some kind of range generator function that lets you automatically generate all values between a defined start and end point. Postgres does have one of those, but I didn't use it here just to make the solution and what I was doing a little clearer to outside observers. Other times, you are working with multiple tables that, when combined, have all the values you need, and you just need to union the corresponding columns from each table to construct your spine, then left join from that to each of the aforementioned source tables to perform your analysis. And there are probably more ways besides, but the fundamental concept is always the same, of creating a net new dataset with all the values you need for your analysis. This is an extremely helpful technique that I have used many times in my career. All right, well, that is it for this video. Thank you all for watching. If you have any further questions about this problem, or if you think of a different approach to the solution that I may not have considered, please let me know in the comments. And be sure to subscribe for more SQL query writing content in the future. Until next time, happy querying.